Welcome back, friends. So, in the last class of differential equations, we introduced ourselves to the definition of differential equations. And then also we defined two important points called as degree and order of a differential equation. We also learned that in solving a differential equation, you will be getting solution, which is called as function of the differential equation. And also, we learned to verify a differential equation when its solution is given. A few sums from the exercise also we have carried out. Now, what we do is, since in the last class we already got a solution and verified it, today we will try to learn how to solve a differential equation. There are many methods. We will, as per the NCERT, since I am telling, we will start with first method called as variable separable method. Okay. Let us go ahead. We'll go to the whiteboard and start solving the sums by variable separable method. In variable separable method, as the name implies, we will be separating x variables to one side, y variable to other side. So first, what is the heading here? Solving differential equations. Solving differential equations. So the first method is called as, for us, variable separable method. So this is the type. Variable separable. Very, very simple. Nothing to worry. We will solve one by one and understand this. Question number 1. Solve dy by dx is equal to x plus 1 divided by 2 minus y. Y is not equal to 2. If y is equal to what happens? 2 minus 2 will become 0. Equation will become infinite. So that is why y should not be equal to 2. So how to solve this now? Dy by dx is equal to x plus 1 divided by 2 minus y. What we said here, variable separable, is separate it out. 2 minus y you send to this side. X plus 1 retain right hand side and send dx this side. So what happened now? Left hand side you are only having 2 minus y dy. That means y dy is present here. So y and dy both are of same category. So you can integrate it. X plus 1 dx, no problem. So integrating both sides, we'll be able to get the solution. By integrating both sides, we'll get the solution for the differential equation. So integral 2 minus y dy is equal to integral x plus 1 dx. Before we go ahead, I would like to tell you some important point here. Suppose you are having integral y dx. For this, the answer is y should be treated as a constant. Only integral dx you should do. So answer is yx plus c. Equally, x dy, if you are having, it is called as x into y. Okay. So even though y is there here, y square by 2 we should not write, because integration is only referred to dx, x variable. So that time y variable, if it is present, should be brought it out. So let us solve this sum now. So integral 2 minus y dy. So integral 2 dy minus integral y dy is equal to integral x dx plus integral 1 dx. So this is 2y, y square by 2 x square by 2 plus x plus c. 2 dy means integral dy is called y. Y dy integration y square by 2. X dx integration x square by 2. 1 dx is x, constant is c. So you can find LCM here. 4y minus y square by 2 is equal to x square plus 2x plus 2c. Here you call c1 divided by 2. 2 and 2 go away. So you can rearrange all the terms. X square plus 2x plus y square. I'm bringing these other terms this side is equal to 0. So write down in order. X square plus y square minus 4y plus 2x. You call 2c1 as c. 2c1 I am calling as c. So this is how we can solve the differential equation. Variable separable method is this now. You are supposed to separate the x variable to one side, y variable to other side, and then integrate both sides. You will get the answer. Let us do the second sum. Integral, not integral, it should be started with dy by dx. Sorry. Dy by dx is equal to 1 plus y square divided by 1 plus x square. Very simple. Dx you bring this side, 1 plus y square you bring this side, you will be getting dy by 1 plus y square dx by 1 plus x square. Now integrate. Integrating both sides. What you will get here? If you remember our basic fundamental formulas, this is called as tan inverse y. This is called tan inverse x and integral constant c. So our answer is tan inverse y is equal to tan inverse x plus c. So please understand, we are finding out general solution. This is general solution, not particular solution. The value of c, if you are able to determine and then substitute here, you will be getting the particular solution. Right now, whatever solution we got is called as the general solution. Next sum. See, next sum they're asking find particular solution. Find particular solution for dy by dx is equal to minus 4x y square. Okay. At 1 comma 1. I remember 1 comma 1. Let me check the question once. Yeah, yet y is equal to, sorry, yet it is happening. Pen is giving something. Just excuse me. Yeah, the x is equal to 0 and y is equal to 1. So at this particular point, 0, 1 conditions, we will resolve the sum. So given sum, dy by dx is equal to minus 4xy square, variable separable method. So dy by y square is equal to minus 4x dx. Integrating integral dy by y square is equal to minus you bring out 4x dx. Dy by y square integration y to the power of minus 2 plus 1 by minus 2 plus 1 is equal to minus x dx. 4 is a constant, it comes out. So x integration is x square by 2 plus c. So now here y to the power of minus 1 by minus 1. Here 2 will go 2 times. 2 you can cancel 2 times. So next page I'll write here. So that will become minus 1 by y, correct? Minus 1 by y is equal to minus 2x square plus c1. So now this is general solution. Now what we do? Put x is equal to 0 and y is equal to 1 in above equation. What you will get? Minus 1 by 1, x value 0 plus c1. So c1 is equal to therefore minus 1. Therefore, particular solution minus 1 by y is equal to minus 2x square minus 1. Minus 2x square minus 1. So now multiply by minus 1, minus sign all through. 1 by y is equal to 2x square plus 1. C1 is equal to minus 1, correct? Yeah, particular solution minus 1 by y is equal to minus 2x square minus c1. So y is equal to 1 by 2x square plus 1. Just the c1 value got minus 1 here. Correct only. Then minus 1 by y is equal to minus 2x square minus 1. Then multiplying all three, you will get like this. Okay. Let us go to the next sum. What is our next sum? Find the equation of curve passing through 1, 1, whose differential equation is x dy is equal to 2x square plus 1 into dx. So what they are giving? They are giving one equation here. Then they said that it is passing through 1, 1. The curve is passing through. So we'll solve this equation by integration and then substitute 1, 1, get the general in particular solution then. So let us see how to do. Variable separable method. X dy is equal to 2x square plus 1. So what you do, you take only x that side. Because there is no y term other than dy. 2x square plus 1 by x to dx. 2x square by x means to distribute your LCM here in this case. Here dy. So dy is equal to 2x plus 1 by x. So integrating both sides. So dy integration y is equal to 2x dx. That means x square by 2 plus log x plus c. Okay, you call c1 better. 2 and 2 get cancelled. So y is equal to x square plus log x plus log x plus c1. Now put 1, 1 in above equation. Why? Because this is the equation passing through. It is passing through 1, 1. So put 1, 1 in above equation. 1 is equal to 1 square plus log 1 plus c1. So 1 is equal to 1 plus 0 c1. C1 is equal to 1 minus 1, 0. Therefore, y is equal to x square plus log x is particular solution. Okay. So we are supposed to know what is the given differential equation and how to separate the variables both sides. Then if any particular conditions they are asking, that conditions we should substitute and then get the final answer. Let us do one more sum. Find the equation of curve passing through -2, 3 given slope of its tangent at x, y is 2x by y square. So this is the condition they give. Find the equation of the curve passing through this -2, 3 given slope of the tangent. So generally we know slope of the tangent means dy by dx. So dy by dx they have given 2x by y square. So you separate variables is equal to 2x dx. Now integrate both sides. Very simple sums, don't worry, easily you can practice. Y square integration y cube by 3. So y cube by 3 is equal to x square plus c1. So what their condition now? -2, 3. So put -2, 3 in above equation. Why? Because it is passing through this point. So first 3 cube by 3 -2 whole square plus c1. So here 3 cube by 3 means 27 by 3, 9, 4, c1. c1 is equal to 5. Therefore, y cube by 3 is equal to x square plus 5, or y cube is equal to 3x square plus 15. You can also write like this. Even if you leave on the top also, we don't lose any marks. Cube root. This cube will become 3 will become 1 by 3 this side. This is the sum. You better always come to the end up to y. Don't leave let y square y like that and all. You go up to the last step. Okay. Next question. So this may be the last example. So there is a bank. What it is doing, a bank gives 5% per annum on its principal. Okay. In how many years? In how many years rupees 1000 becomes double? So in how many years 1000 rupees will become double? They give 5% per annum on the principal. So very simple. Let P be the principal. Given dp by dt means rate of change of your thing is 5 by 100 of P. This is a condition 5% per annum on the principal. So principal if it is P, dp by dt will be 500, 5 by 1000, 100 into P. So now here, this is called 1 by 20. Okay. So now you can do variable separable. dp by P is equal to dt by 20. So integrating both sides, you'll be able to solve the equation. What we'll get, log p is equal to integration of t is dt is t. So t by 20. So this is the base for e. If no base, if 10 is not given, we should take as natural log e. So that means p is equal to e to the power of t by 20 plus e to the power of c1. So this e you can apply to both sides. This will become now, 1 second, this one. E to the power of t by 20 plus c1, which you can split like this. So p is equal to e to the power of t by 20. E to the power of c1. This e to the power of c1 we can call as c. Okay. Now what are the initial conditions here? So now put p is equal to 1000 at t is equal to 0. So to solve the c, then 1000 is equal to 1000 is equal to e to the power of 0 by 20 into c. So here 1 will come into c. So c is equal to 1000. Therefore, our general equation now, p is equal to c into e to the power of t by 20. That will become 1000 into t by 20. Okay. So what we did is we have substituted 1000 here for the principal and then got the value of c. Now, what we have to do is now, when in how much time it will become double. So let t be the time in which rupees 1000 becomes double. That means 2000. So that means in your equation, 2000 is equal to 2000 is equal to 1000 into e to the power of t by 20. So we can cancel both sides. Zeros. 2 is equal to e to the power of t by 20. Correct or not? So therefore, log of 2 to base e is equal to t by 20, or t is equal to 20 log e, log 2, sorry, 20 log 2. So this is the time that requires for your 1000 to become 2000. So dear friends, hope you are following the sums. Very simple, variable, separable. And in the next class, we'll try to see some more sums. Keep practicing differential equations. Thank you so much.